Hello, welcome to the second tutorial series on Stephen Barr Games. This time around we'll be looking at how to create a Space Invaders style of game using Unity and C#. Like with the 2D platformer in the previous tutorial, we will only use the basic shapes available to us from within Unity, as well as writing some simple scripts in order to get the game running. Let's start out then by creating our project. So go ahead and open Unity and set the project name to whatever you feel like. We're going to call it Space Invaders just here, and then select 2D, and you can also select the location there and create the project. I'll just give that a second to load up, and we're into our project straight away. Then what we want to do is go to our project tab, right click in the assets folder and create a folder. We'll name this folder materials. We're just going to create 3 more folders. So create another folder and name it scripts, then a prefabs folder, and then a scenes folder. Now if you click into the scenes folder, it's empty now, and what we want to do is go to file and save scenes, select the scenes folder and name your scene. We're just going to call it scene 001 and save. Once you've saved the scene, you go back down here and you'll see that the scene is now appearing in your scenes folder. Next, what we want to do is to just set up the camera. By clicking on the camera, we'll set the size of it to 7 and the flags there to solid color. You can just change the color to black, as you'd expect in a Space Invaders game. And if we go to our game scene, we'll see that it is a black background now. Next, we want to right click on our camera and create a directional light. And that'll be a child of the camera component. And as you can see here, it is just pointing directly at the scene, which is great. We just want it to be pointing straight at the scene for now, then drag it up out of the way. And you can also change the angle there if you want, or the size. We'll just set it to a 10 on the Y. The next thing we're going to do is to create a cube that we can use throughout the project. So if you right click and add in the 3D object cube, and then remove the 3D box collider, and then add a box collider 2D and add component. Then we want to drag that cube into our prefabs. So it's pre-made there. We don't need to add in a 3D cube every time. We just drag in this cube with the 2D box collider already attached. Now, if you just delete that from your hierarchy, just as an example to show how to do that, and you drag the cube back in. Now rename this one player and change the tag to player. What you want to do next is go to add and add component rigid body 2D and rescale it there. So we want it to be 0.5 on the Y scale, so it's a bit flatter. And then once we've done that, just look, everything else seems to be okay. And then we want to drag in another cube, but attach it to our player as a child. And we are going to rename this cannon, which is going to be the cannon that fires, obviously, at the enemies from the player. Let's change the size here though, so it looks more like a kind of like a little cannon that's coming out of the player. So put the X scale to 0.5 and the Y position to 1. And as you can see here on our scene, we have a kind of pointing out of the player at the top. For this one, we want to remove the 2D box collider also, and add another box collider onto our main player, but then resize it so that it covers the cannon. And this will be useful later whenever we're writing some scripts that can actually kill the player, so that we only need to attach it to the player instead of the player and the cannon. And down here we just kind of fix the offset of the box collider just to even those numbers out. And tidy things up, I like to put the box colliders next to each other, so we just moved it up a bit. and close it up now. That should be it, looking fine for now. What we want to do next though is add a material, because we want to change the color of the player. We don't want it to just be plain white. So let's right click and create a component material and call it matte green. Then go over to the hierarchy here and change the color. So we just mess about here and see what color looks good to us. And once we have the color, just change the shadows a bit there as well. Okay. And we have the color. So once you have that, you just drag the material over and onto the player and onto the cannon, and you'll see it just recolors it then. We also want to reposition the player on the screen to be in line with where the player will eventually be whenever we are playing the game, and in this case it's around -6 on the Y position in the player transform. And now that we have that set up, we want to also constrain the player so that the player, whenever moving later, doesn't roll around. So we freeze the Z rotation and the Y position in the constraints of the rigid body. Right, that also stops the player, from falling off the scene, so the rigid body. Next, go to the scripts folder and right click and create a C# script, and we will name it player controller. And as you probably guessed, this is going to be used to move the player. Double click on that so it opens up in MonoDevelop or Visual Studio, whatever you prefer, and type in private transform player. Next, after that, what we want to type in is public float speed. Then after that, we type in public float max boundary, just max bound and min bound. These are going to be used to stop the player from moving off the side of the screen. We also want to go to the start and type in player equals get component transform, and this will find the player's transform component, and that'll be the one we reference from here on out. In the update method, type in float h equals input.getAxis horizontal, which is the A and D keys or the left and right arrow keys to move the player. And we write if player.position.x is less than the min bound and h is less than 0, then what we want to do is set h to 0. So essentially what that does is, if the player is at the far left side of the screen and h is still negative, which means you're trying to move left, it'll stop you from moving by setting h to 0. We do the same thing essentially for the right side of the screen. So else if player.position.x is greater than the max bound and h is greater than 0, and if it's greater than 0, that means you're pressing the key to try and move. So we set it to 0 to ensure that you can't move. And what we want to do now is to type in our little bit of code here that actually moves the player. So player.position plus equals vector3.right multiplied by h times speed. And essentially that is vector3.right. It's just a vector3 component, only it's 1 on the x to move you to the right. We drag that in to our player model, and as you see, our speed, max bound and min bound are all set to 0 right now because they're public components. We didn't actually, they are public variables and we didn't set them in the code, so we can just go ahead and set those here. We'll do 0.1 as speed, 10.5 for our max bound, and our min bound will be minus 10.5, just the exact opposite of the max. It's the opposite sides of the screen. Let's see how that plays. As you see there, we can't really move any further than the bounds. We can't at all. And that stops the player. Going back here, you may think that you might want to change the max and min bound to something else because it didn't move quite to the edge of the screen. But that's up to yourself. Next then, we'll drag in another cube from our prefabs folder. We're going to rescale these and set it to 0.1 for X, and for Y we'll set it to 0.3. Go ahead and rename this to bullet. This is going to be the bullet that we shoot at the enemies. Add a tag, and we will name this tag bullet. Go back to the bullet, and at the tag there we will just add bullet into it now. So it has been finally tagged as bullet, and we can use that later. Set the box collider 2D as a trigger, and then go to physics 2D and add a rigid body. We want this to be kinematic, as we don't want whenever we shoot it or anything for it to have any forces acting down on it to push it back towards the player. We want it to shoot right off. Create another material here and call it matte pink, and set the color to a pinkish color. Just you can mess around there for a bit and see whatever suits best. And once you've done that, you want to drag it onto the bullet to change the color. Next, you want to go to the scripts folder, right click and create another C# script. We will call this one bullet controller. And we're going to use this for the script that basically programs the bullet to shoot out towards the enemies. We can start off this script by creating a private transform, and for this one we just call it bullet. Once you've done that, you want to create a public float called speed also, and we'll obviously use that to control the speed at which the bullet moves. Go to your start method and type in bullet equals get component transform, and make sure you add in the brackets like shown. And what we want to do is create a void fixed update. We want to use fixed update for the bullet to make sure that it moves every set period of time instead of every frame, because the frame rate may change, but we don't want the speed of the bullet to change. So bullet.position plus equals vector3.up, which sends it off in an upward direction, and we want to times it by speed to change how fast the bullet moves upwards. If bullet.position.y is greater than or equal to 10, what we want to do there is to destroy the bullet. The reason for this is if the player keeps shooting out bullets, and eventually we'll have a whole bunch of bullets being processed in the background, it can cause performance issues with the game. So we want to clear the bullets after they're off the screen so that they're no longer being rendered. Next, we want to do void on trigger enter 2D and set collider 2D other. And if the other.tag is equal to enemy, which we will create later, but if it is equal to enemy, then what we want to do is destroy the enemy game object. So destroy other.gameObject. But we also want to destroy the bullet. So we go ahead and type in destroy game object. Similar to how we destroy the bullet when it gets too far off the screen. We just do it here as well when it hits an enemy. And we just leave a little note in here to increase the player score also when you hit an enemy, but we don't have that quite yet, so we'll just put in the note to add later. Else if we hit another object In this case, if we hit the other.tag equals base, we're going to create some bases as well. We want to just destroy the bullet and do nothing. We don't want to take damage to our base. All we want to do is destroy the bullet. So else if other.tag equals to base, then destroy. So before we create any of the scripts for the player controller to shoot the bullet, let's see what the bullet actually does now. Whenever we click play, you'll see there it's just staying still. So what we want to do to make sure that that works correctly is to drag the bullet controller onto the bullet and set it to a speed of 0.3. Now let's see what happens. Whenever we click on play, the bullet just zooms off the screen there. That's exactly what we wanted to do. Now back to our player controller script. We're going to write some code here to allow the player to spawn and shoot a bullet. So public game object shot and public transform, and it's going to be the shot spawn, so we're the position that we want it to appear, and then public float fire rate. Also create a private float and call it next fire. Right, so in order to do this, we need to get some sort of user input to shoot that. Oh, and before there, the previous update, just change that to fixed update. It actually should be fixed update. That was my mistake. We want to go ahead now and create the update method. So void update, and in here we want to check if the input.get key down, we'll get button, and if we're pressing the fire 1 button, which in this case is the left mouse click, and so if we get the fire 1 button and the time is greater than the next fire, then what we want to do is next fire equals time dot time plus fire rate. Once we've done that, we want to instantiate the shot and the shot spawn position and the shot spawn dot rotation. So this creates the shot, which will be our bullet, in the position we want to set it and with the rotation that we want to set it. Also, next fire equals time.time plus fire rate is just essentially taking the current time, adding on the rate of fire, which could be something like 2 seconds or half a second, and figuring out when the next time you should be allowed to shoot is. So with the player script there now updated, we want to drag our bullet into the prefabs folder, and then what we're going to want to do is drag the game object off the bullet into our shot component. Okay, so delete the bullet off the scene, click on your player and drag the bullet into the shot. And we want the shot to spawn on our player's transform. So we want it to spawn at the same position as our player. And we want to be able to fire these shots every set period of time. And in this case, we'll do it as 0.5. And as you can see there now, we can't spam the shots really fast, but we can shoot them about every half a second, which leaves a little bit of a delay there, making the game a bit more challenging than if you could just shoot infinitely as fast as you can click. Next we want to create another game object here in our scene. So drag in the cube from the prefabs and we will call it base. If you remember before, we did script the base in the bullet controller. Add a tag, call the tag base, and set the base tag to base. We want to scale this a bit bigger now, so we'll go for a 2 on the X scale, and we'll leave Y as 1. We also want to add in a rigid body so that our trigger from the bullet can react with it, and then set the rigid body type to kinematic. We don't want the base to be able to fall or move. We just want to set it in position and let it stay there. Go to the materials folder and right click and create a material. Call this matte dark green, so it'll be the similar color to the player, only a darker version of the green. Drag that onto our base. If you look there now, we have the components added in. We just need to reposition our base as well. So right click first though and create an empty game object and call it base underscore holder. And as you probably guessed, we're going to just drag our base into that. Reset the base holder to a position of 0. And then drag the base in. Okay, so with this we're going to need more than just one base, and we're going to need to position the bases at the right place within the base holder. So go to our base and set the X position to -9 and the Y to -5. Once you've done that, you're going to want to create another copy of the base. So right click on our base and Control C and then press Control V, then set the position there. So we're going to have 4 bases, so we want to get the position kind of right in to have them evenly spaced out. So we'll set this one to 9, which is the complete opposite side, and then we'll set the other 2 to 3 and -3. So there's -3 and then 3. That way each base is spaced out by a number of 6 on the X position, or on the position's X-axis. As you see, we now have 4 bases in our scene, and we want to create a C# script called base health. Double click it to open the base health, and in your developer, let's see, just a little issue there. Yeah, so we double click it to open. In the developer, we want to start writing the script to add some health to the base, so that whenever our enemies do attack the base, that they take damage and can be destroyed, which is one of the ways you can lose the game and get the game over screen. So type in public float health equals 2. Remove the start method, and in update type if health is less than or equal to 0. Then we want to destroy. So that's the script written there. You just save the script and go back to Unity, and what you want to do is get the base script and drag it onto each one of the bases that we have created. So make sure you drag it onto all 4 bases individually and save your scene. And we can just go ahead and close the base holder to tidy up the hierarchy. The next thing that we're going to want to do is to create a script, and this script is to determine if there is a game over or not. So create a C# script and name it game over. double click on that script to open it in your editor. And what we want to do here is to just write a quick script that determines different ways in which the player gets a game over and basically loses the game. So we want to go up to the top there and type using Unity engine .ui. So we want to use the user interface to basically display some things on the screen as well later. So type as well public static bool is player dead and set it to false, because obviously we want default to be that the player isn't dead and that they're still alive. And then create a private text game over, and that text there is which is why we need the Unity engine.ui. Go to the start method and type game over equals get component and put text in there. So get the text component. Then we want to have game over dot enabled equals false, and this ensures that the text that mentions or that shows it is a game over is not enabled at the start so nobody can see it. We'll later enable it when the player is dead or loses. So in update, type if is player dead. So if that equals true, then time.timescale equals 0. It essentially pauses everything, freezes the game. And then game over.enabled equals true, so that the game over text is displayed on the screen and everything stops moving. Just tidy that up a bit by removing some notes. Save that as well. Save the script. We're back into Unity. We want to create another C# script, and we will name this script base defeat, and double click base defeat to open it in the editor. And go to the top and type in private transform player base, and then go to start and put in player base equals get component transform. This is to initialize the player base by getting it to transform. Now, in update, type if player base dot child count equals 0. So this looks at the amount of bases you have left. If you have 0 bases, then we want to set game over dot is player dead equal to true. So we look at our game over script, we check if the player is dead. We look at our game over script and we set is player dead equal to true because we have 0 bases left. If you lose all your bases, you lose the game. We go back here as well now and we take our base defeat script and we go ahead and drag that onto our base holder. So make sure it's on the base holder and not just one of the bases. As you see there, so with the player base child count is 0, just going over that again, then the player that is player dead is set to true. Next up, what you want to do is right click in the hierarchy and create some text. Rename the first piece of text score and type in score colon 0. So initially it'll say you have 0, and then we will write a script as well at a stage later that'll update that. You can also zoom out there and reposition score so that it's in a better position on the screen. You can click here and set it to the bottom corner like that. Drag this out a bit as well, and that way we can go ahead and resize the font and things. And then set position X to 195, and for position Y, We don't want to set it to 200, but set it to around 25, which is what we're going to change it to here now. Sorry, so change position X to 220 and position Y to 25. Add the width, or change the width to 400 and height to 50. And we want a font size of 36. Uncheck best fit and change the color to white. And center it, or set it to the left, sorry. Right click on the canvas and add in more text. This text, the first one we want is to be game over. And for game over, we of course want to position it again. So we want that to be in the center. We want it to be stretched in the center so that it stays the right size, no matter the screen resolution. And change the font size also to this for the game over message to be 134. And go ahead and select whatever color you'd like it to be. Let's see if we can adjust the sizes here, see what looks like a good size. So try setting right to 150, height to 160, set left to 150, and position Y to 0. And then the text, just obviously we want it to say game over and centered. And there we have it. We can enable and disable that depending on whether you have a game over, and it'll appear in the middle of the screen. Right click on canvas and add more text, UI and then text, and we want to name this restart. This is going to be another message that appears that basically says the player to press a button, press R to restart. It's just going to be there after you get a game over message. We want to set the size of this to 55, and then like the game over message, we want to have it stretched. And then just position it as you like, center it, and you can change the color and that also. First, let's just change the right position to 195, the left position to 195. Then position Y, we want to set that just so that it's just underneath the game over. So about minus 150 seems to be okay. And put the height at 80, which is a nice round number. Okay, so go back to game over. I want this to be the same color as game over. So what we want to do is just copy that little hex color. Just copy and paste that then into here. That way they'll both be the same color whenever they appear on screen. And finally, right click canvas, go to UI and add another text component, and this time we will call it win. So rename it to win. Go down to the text and just type in you win, or whatever type of message you would like to be displayed to the player whenever they win the game. And we have the width of this that we will set to 800, and we will also make it stretch so that it'll vary depending on screen size. We want the font to be 134 and centered. And then we just copy and paste in the same color for the you win message as we did for the others. It may make more sense to have the you win different from the game over, and that's up to you. You can just change and mess it around. This is just whatever I'm doing for the sake of this tutorial. Now you go ahead and you can disable these components as well by unchecking them so that they don't appear immediately. But we also can do that through scripting. And we just drag the game over script onto both game over and restart. That way they are both affected by it and will both just appear whenever the player reaches a game over. It essentially is just checking constantly every update if it is true that the player is dead. So right click and create a new C# script and call it restart level. And as you've probably guessed, this is going to be the script in which we get the player to press the R button that completely restarts the level for them. To do this, we have to type in using Unity Engine .scene management. This way we can reload a scene and restart the level anytime the player presses the R key. So delete the start method and in update type if input dot get key down, and we have keycode dot R. So we're checking if the player presses the letter R on their keyboard, and if they do that we will restart the scene. So start by typing in this script here for player score dot player score equals 0. Now we don't have that created just yet, but we will be creating a script later that'll be the player score, so we can just comment it out for now. But we also want to set game over dot is player dead equal to false, and then time dot time, so time dot time scale equals 1. And if you remembered previously in the game over we set it to 0 so that everything froze, but when we set it back to 1 everything starts working again. And then we have scene manager dot load scene, and that is scene 001. This is essentially whatever you have named your scene. So if you've named it something else other than scene 001, then you just put that in there instead. Now create another C# script, and now we are going to create player score. And double click it to open it in your editor. Go to the top there and type using Unity Engine.ui, because we're going to be accessing the UI from here as well to edit the script, or sorry, to edit the text for the player score. So we need a public static float, and we have to make it static so that we can update the score from the other scripts. So public static float player scores equals to 0, because it always starts at 0. And then we want private text score text, which is going to be the text that we added in there just a moment ago. Set the score to 0 to begin with. Score text equals get component, and we're going to find text, so we want the text component. Now to get the update and change the score anytime the player gets any points. So score.text equals score plus player score. So this is constantly updating. It's checking what the current score is and updating the score on screen to match it. Go back to our restart level and uncomment out player score equals 0. The reason for that is every time you restart the level we want the score to go back to 0. If you don't have that in, then the score from the previous games will just be displayed. And you remember previously in the bullet controller we had in a comment there for the player score, and what we want to do is when you destroy an enemy to have player score plus equals 10. Every time you kill an enemy you get 10 points, and that adds to your score, and it will then update on the screen in the text component. If we minimize that, make sure everything is saved, all of your scripts are saved, and then create an empty game object in the hierarchy, and you want to call this restart. So drag restart level onto this empty game object for restart. That way we can ensure we can call it at any time during gameplay. Make sure you go to the text components of the game over and restart objects and uncheck it so that they do not appear on screen. Do the same for win. The only one we want to appear at the beginning is score. So we see here we've made a little mistake in the code here, so we just go back. Let's see what we've done. Okay, so it's just a bracket, so you don't need to worry about that. And let's play the game, see what happens. Right, so we haven't tried the game here in a little bit, and obviously we notice here now that the bases are too low, so we're going to need to higher those up. We can just take the base holder and drag it up a little bit so that they're out of the way of the player. Set it to about 0.5 on the Y, and there we go, we can go right under those. Perfect. So far you can see we have the scene pretty much set up here, but we have no enemies at all, which is what we will need to create in order to have an actual game. And you notice there, whenever I'm moving to the side, I press the R key and it's immediately restarting the scene, and that's why the player is jumping back to the center. That is the scene being restarted. Okay, now let's create some enemies. Drag in your cube and rename it enemy. This is going to be the first enemy that we create. Right click in the materials folder and create a new material called matte white, and just basically mess around there with the colors and the emission to get a nice bright white color, and drag that onto your enemy. Now, for the sake of this, we're just going to add a tag and call it enemy, and then assign that to the enemy object. Then add your component for the rigid body 2D, so we can apply physics and triggers to the enemy. Freeze, Z rotation, and Y. This is similar to what we did with our player, so we want to freeze both of those so that the enemies don't rotate if they end up colliding with anything, and they don't just immediately fall unless we script them to move downwards. So we made a copy of enemy and renamed it as leg and removed all the physical, the 2D box collider and the rigid body 2D. We are then rescaling it to 0.1 and 0.1 of the size of the enemy. Then we just drag it down into place. We're just going to quickly create a little enemy here with this game object without any of the colliders or rigid bodies on it. And there we have it, that is the enemy created. And we just tidy that up a bit and go into our scripts next. Another C# script. And you want to rename this script the enemy controller. and double click to open up the enemy controller script. We'll write some things in there to control the enemy. First thing to do is go to the top of the script and type in using Unity Engine.ui. Then inside the class, type private transform enemy holder. Then public float speed. And in the start method, what you want to type into there is, before you do that, go back to the top and type public game object shot and public text win text, and also public float fire rate. And we can set fire rate to 0.997. Then in start, type winText.enabled equals false. And we want to invoke repeating on move enemy. Set it to 0.1f and 0.3f. And enemy holder equals get component transform. And we can remove the update for this one and instead put in void move enemy, which is what we've invoked there just above. We have enemy holder dot position plus equals vector 3 dot right times speed, and we want to go for each transform enemy in enemy holder. So we want to go through each enemy that we have placed inside our enemy holder. And we want to check if the enemy position dot x is less than minus 10.5, or do the two lines for or. We want to check if enemy position dot x is greater than 10.5, so that's minus 10.5 at one side of the screen and 10.5 at the other. Then we want to have speed equal to minus speed, which reverses the direction in which the enemy is moving. And we also want to have enemy holder dot position plus equals vector 3. And we're basically going to make the enemy move down on the screen, or all the enemies together. So we have vector 3 dot down times 0.5f. And then we return. So if that's true, we just return and jump out. And we also want to check if enemy.position.y is less than or equal to minus 4. And if it is, we do game over dot is player dead equals true. So if the enemy reaches the level of minus 4, which is when they're at the bases, then the game is over and the player is dead. And we freeze the game by having time.timescale equal to 0. And if enemy holder dot child count equals to 1, then we cancel the invoke, and then we go ahead and invoke it again. So we want to stop the initial invoke, but we want to do it again with a quicker speed. So we call move enemy, but this time we call it with a time of 0.1f and 0.25f. And if enemy holder dot child count is equal to 0, then we want the enemy to lose and the player to win the game. So win text dot enabled equals to true. And it'll come up on the screen letting the player know that they have won. And in here we just leave a note saying enemy bullet controller is called too. So we want to call that as well, but we need to actually make that first. And before we create the bullet controller, we want to create the enemy's holder, which is an empty game object. So you create an empty and then rename it enemy holder, or as I do, enemy underscore holder. And the first thing you want to do to the enemy holder is add a rigid body 2D. That way we can move it about and apply some physics and freeze the Y position of that so that it doesn't just fall whenever we start the game. Next, drag on the enemy controller to the enemy holder. So drag our script onto the enemy holder and then drag the enemy that we have created into the enemy holder so that it becomes a child of it. If we click play, and we can shoot the enemy with our player and it destroys the object. What we want to look at now though is that we need to have the enemy also shooting randomly back. First add the win text, and that way whenever we shoot the player or the enemy, it pops up you win and the player knows that they have won the game. So go into our prefabs and drag in the bullet that we created earlier and just rename that enemy bullet. And change the tag of it to enemy. Go ahead and remove the bullet controller script also, and back into our materials folder, create a new material and name it matte blue. And pick the color there, so whatever shade of blue you like best, and drag it onto our bullet, our enemy bullet. In the scripts folder, right click and create a C# script and name this enemy bullet controller. And open it by double clicking on it, and in our editor we're going to start writing the script that will move the bullet. So the first thing you want to do is type in inside the class private transform, and we will call it bullet, and then public float speed. In the start method, type bullet equals get component transform, and do your little pointed brackets around it, and then your normal brackets at the end. Also, we want to have void fixed update, and in fixed update type bullet position plus equals vector 3 dot up, and multiply it by negative speed so that it goes in the opposite direction. if bullet dot position dot y is less than or equal to -10, then we want to destroy the bullet. That way we don't just have a crazy number of bullets being processed by the engine there, and we just destroy them off to help performance. Next up, we want to do void on trigger enter 2D and put in your collider 2D, and we'll name it other. We want to check if other.tag is equal to player. We want to check if the enemy bullet is hitting our player. To do that, we just destroy the player once we detected that it is collided. Destroy other.gameObject, and we also want to destroy the bullet, so we just destroy gameObject. And the last thing we do is to set the game over condition that the player is dead, which is gameover.isPlayerDead, and that equals true. Then we want to go else if other.tag equals to base. If it equals to base, then we want to set gameObject player base equals to other dot gameObject, and then what we want to get from that is the base's health. So we go base health, and we just call it base health, and we equals player base dot health, or sorry, it equals player base dot get component base health. We want to get the base health from the base that the bullet has collided with. And then obviously we're going to take some of the health away. So base health dot health minus equals 1. So we just take 1 off the health for every bullet that collides with a base. And destroy the bullet. So destroy gameObject. And save your script. Back into the enemy controller, we want to update it with our bullet controller in there as well. So if random.value is greater than fire rate, so we're going to randomly spawn bullets from the enemy, or from the enemies, yeah. Instantiate our shot, and in the position of the enemy, so enemy.position, and then at the same rotation as the enemy as well. So we want to basically create a bullet randomly every so often and fire it from the enemy. Go ahead and drag the enemy bullet controller onto the bullet. And then we need to set the speed in there. So go ahead, and for the speed we'll put in 0.1, and drag our enemy bullet into our prefabs. And then drag the bullet, delete the bullet from the scene, and drag the bullet from our prefabs into the enemy controller script for the shot. Because the shot is the bullet, that's what we want to spawn. And set the speed to 1 in there as well. And there we have the enemy moving. We shoot our bullets. Eventually we will hit the enemy, or the enemy will get us. There we have it. And that's pretty much set up now, except for all we need to do is add in more enemies. So what we want to do now then to set up the rest of the enemies is just reposition the enemy a little bit there on the screen and duplicate the enemy by copying and pasting the enemy within the holder. So let's just do that now. So we'll set the first enemy to 10 on the X and 0 on the Y. And what we want to do is copy the enemy, paste in another enemy, and just set that right next to the enemy at a position of, let's see, around 8.5, so a 1.5 gap between each enemy, or rather 8.75. So there's a gap of 1.25 between each enemy. We want to just repeat this each time. So let's look at another one. This will be at 7.5 and then 6.25 and so on and so forth. Let's speed it up a little bit here to just show you this. So we've got about 10 enemies per row, and then we can highlight them all to copy an entire row and drag those up. So from 0 up to about 1.2 on the Y, so each time the Y axis will go up 1.2, and again you can highlight the full row and copy and paste it. And let's speed that up again to just show you here. And there you go, you have a full group now of enemies, and they all move in unison together, and they will randomly fire at you. You can increase the fire rate if you want to make the game more difficult, and you can increase the speed of the enemy movements in the scripts as well. Just watch and see how this game goes. And the final enemy, as you see, speeds up when it's the last one remaining, making it harder to get the last enemy, but once you do, you win. Or if you don't get it and the enemy reaches the bottom, or they destroy your bases, then the enemy can win. So this is just to show what it's like to lose. Game over, press R to restart, and when you press R, the game immediately goes back to the beginning. Okay, so that's the game created there. Just close up the enemy holder, and what we want to do next is to actually build the game. So go to File, Build and Run. We just created for PC, Mac and Linux, and just click Build and Run. You can name the file here. Let's just call it Space Invaders. Okay, and the game builds here. Just take a moment. It's built. You just click, you can select your settings and then play, and here we have it opening up with the Unity logo, and you're straight into the game. That's the final game here created. As you can see, it's a fairly basic version of Space Invaders. Doesn't have any of the ships that randomly appear across the top, and just a simple type of enemy moving back and forward. You can obviously work with this and try and add in some of those other features if you like, but as of right now we have the simple enemies with the score at the bottom left hand corner, and once the enemy reaches the bottom, it's game over. Press R to restart, or if you defeat the enemies, obviously you can win. And that's pretty much it for this tutorial. Thanks again for tuning in. Don't forget to subscribe if you like this, or leave a comment letting us know what else you'd like me to cover. And thanks again now. Bye.